Okay, in this presentation we're going to look at complex numbers. This is a tutorial question. So it's broken up into two parts, and essentially the first part is as follows. We have two complex expressions here, p plus 2I, and we don't know what p is. Well, we know it's an integer. That's important. Okay, it's an integer. And z2 is equal to 1 minus 2I. Okay, so the question asks us, the first part of the question is express this fraction z1 over z2 in the form a plus ib, standard Cartesian form. Okay, so this is straightforward enough. Essentially what we do here is we look at the denominator and we sort of decide what the complex conjugate is. Essentially it's just changing this sign into this sign, okay? And what we do there is we multiply the expression, this expression here, by the complex conjugate above and below the line, okay? Because that is essentially equal to 1. Something divided by the same number is equal to 1, so we're just multiplying by 1. So that's it really. That's just a complex conjugate multiplication that helps us with division, okay? So looking at the denominator first off, 1 minus 2i times 1 plus 2i, that actually just ends up as a very simple calculation, which is 1 squared plus 2 squared, which will end up as 5 later on. So the denominator of this expression will end up as 5. We look at the numerator now, so that is p plus 2i times 1 plus 2i, and working this out, we get p times 1 gives us p, 2i times 1 gives us 2i, p times 2i gives us p times 2i, or 2pi, and 2i times 2i gives us 4i squared, and necessarily that will actually end up being minus 4. Okay, so the real parts are as follows: p and minus 4, so we have it here, p minus 4, it ends up down here, and 2pi plus 2i, that ends up here. Okay, so that is our expression in the form a plus ib. Okay, so it's a complicated looking expression, but that is just basically the gist of what we are looking for. Now, the second part, this is part B, and what it tells us is that the absolute value of z1 divided by z2, the magnitude, is actually equal to 13. Now, here's what we can say. This expression here is directly equivalent to this expression here, that the magnitude of the numerator, that is equal to the magnitude of the numerator divided by the magnitude of the denominator. Okay, so essentially what we're going to do is multiply both of these expressions out. So solve them out. Okay, that is p. That will work out to be p squared plus 2 squared. Get the square root of that. The square root of p squared plus 2 squared. That works out to be the square root of p squared plus 4, okay, and 4 being inside that square root. Likewise, the denominator is 1 plus minus 2 to be squared. That will end up as minus 5. Okay, so we have the square root of p squared plus 4 divided by the square root of 5, and that is equal to 13. Okay? So essentially what we have to do is just work this expression out and solve it. Okay, so what I'm going to do here first off is square both sides. So for example, 13 squared becomes 169. And this expression here, essentially I just take out the square roots. So when I just take out the square root above and below the line, I end up with p squared plus 4 divided by 5. That is equal to 169. Okay, so just to simplify things a little bit further, I am going to multiply both sides by 5. 169 by 5 gives us 845. So p squared plus 4 squared equals 845. So what happens there is, oops, I just jumped on too far. I'll just give myself some room. Subtract 4 from both sides. we end up with 841, and when you get the square root of 841, you'll find that it's 29. Now, just to be clear, in this particular instance, usually when you get the square root, you assume that it's the positive one, but in this particular case, you will get a lot of negative ones as well. So it would be typical in this particular branch of mathematics to, when you do the square root, just say plus or minus. Okay, so it's plus or minus 29. Actually, that was hinted at in the question, the range of what possible values. Okay, so now that I recall, it was stated in the question, what are the possible values? Okay, that's it. Yeah, thank you. Bye.